Welcome to Pravdan Tutorials. Please kindly subscribe. Thank you.
Hi everyone, and welcome once again. In the part 1 of this differentiation of a tangent function, we established that when you differentiate a tangent function, we are able to show using quotient rule that the differentiation of tan will give you sec squared x, or we got 1 plus tan squared x. In this video, I will be taking you through some typical examples and for better understanding. Okay, so let's start with a very simple example. Example 1. Let's say we have y equals tan 7x. Okay, so if we differentiate this, what are we going to have? If it's objective, we can just get the answer straight away. And how do you do that? Close the tan and deal with 7x first. If you deal with 7x, differentiate 7x, what will you get? When you differentiate 7x, remember, it will leave you with 7. Now close that and deal with tan. Remember, when you differentiate tan, what do you get? You get sec squared. So replace back with this, that's a 7x. This is a quick way, this is objective. If you are to do using, if it's a theory question and you have to show your workings, it's quite simple. I'll quickly show you that as well. Let's say we have y equals tan 7x. You're going to use the chain of function of a function here. You can say let u be equals to 7x. Then you are left with y equals tan of u. Remember, you have to differentiate this, so I do du dx, and that's going to give you 7. Okay, and you also have the y du. Differentiate y with respect to u, which will give you sec squared u. Then remember, according to your chain rule, you bring these two together. That is your du dx multiply your dy du. That is going to give you dy dx. And that will be 7 multiplying sec squared u. And that leaves you finally with 7 sec squared u. It was used as a representation to mean 7x. Okay, so that's that. So if we know this, okay, so quickly, so that's just it, differentiating this kind of function. So let's look at an example 2 now. If you have this kind of question, y equals 5 tan, let's say, cube 7x. Yeah, let's go a little bit advanced. So how do you do this? It's quite simple, but you still have to apply a function of a function. So in this case, what you're going to do is let u be equals to, because this is power 3, yeah, okay, so which belongs to tan of 7x. This is like saying something like this. This is like saying tan 7x power 3, okay. That is what it means, which is tan cube 7x. Okay, so we make a representation for this. So we say let u be equals to tan 7x. Okay, if we do that, then what do we have? Y will now become 5 tan 7x. Look at this, has been represented as u, so you'll be left with u, then put the power 3 on top. Okay, yeah, we need the differentiation of u with respect to x, which will give us, when you differentiate tan 7x, you get 7 sec squared 7x, according to the first example. Yeah, and when you differentiate this, the y with respect to u in this case, it will give you, the coefficient is 5. Remember, you must drop the power 3. We write the variable u subtracting 1 from the power, which leaves you with 2. And this is 5 times 3. 15u squared. And what is the next thing? The same thing we've done before now. Now you can have your dy dx to be the product of u dx and dy du, which leaves you with 7 sec squared 7x multiplying dy du, which is 15u squared, and that leaves you with 7 sec squared 7x multiplies 15. U is tan 7x, tan 7x all squared, and you can simplify further to have 7 sec squared 7x multiplying 15. This tan 7x all squared can be written as tan squared 7x. And finally, since they are multiplied, we can multiply 7 and 15, which will give us 105. Then we are left with sec squared 7x tan squared 7x. Alright guys, that is it. Solve more examples and have a nice day. See you at Prof. Dan.
Please kindly subscribe. Thank you.